Bismillahirrahmanirrahim. Assalamu alaikum. This is the 26th lecture of Formal Methods for Software Engineering, and I am Fakhr Lodi with you. In the previous lecture, we started to discuss the development of a filing system. How to write specifications of complex systems by using already defined specifications. So the approach that we took was this filing system was, relatively speaking, a complex structure, complex entity. So we took the divide and conquer approach, and we said that we would be developing specifications for smaller entities, smaller sorts, and then we will be using those sorts to develop the specification of this bigger entity, that is the filing system itself. Let us have a look at the overall structure of the specification. In the specification, we said the filing system will be developed by using specification for bimap, which will be developed by using the specification of list and pair, which will be developed by using the specification of Boolean. So we will have this list, pair, and quad. They will all use the Boolean. Boolean will also be used in the filing system. This quad, pair, list, and bimap, they will also be used by the filing system. And the bimap will be developed with the help of this list and pair. This is the overall structure of the specification that we are developing. How did we come up to this particular structure? This is not the topic of this discussion. जिस तरीके से आपका एक ऑब्जेक्ट ओरिएंटेड एनालिसिस होता है, so you have a bigger problem and you divide that problem into smaller problems. एक मॉड्यूल का आप डिज़ाइन करते हैं, you identify the classes in that module, and then you identify the operations and the attributes of those classes, and the linkages with other classes. It is a very similar process. We probably came to this structure after analyzing what is required by the filing system and what would be the smaller components of that filing system. So how did we actually come to this point, come to this particular structure, is not within the scope of this discussion, not within the scope of this class. Once we had this structure, the question is how to use it. And I have not yet talked about the pair and the quad and the bimap itself, and why did we need them. I'm not going to talk about why did we need them from an analysis point of view, but I will show you how do we use them in building the bigger specification and what is meant by those smaller pieces. In the last lecture, we saw the specification of Boolean and list. These specifications were essentially the same as we saw in the previous lectures. So there was very little new in those specifications, except that we used the infix notation, and we also talked about parameterizing the specification itself. Last time, we started to discuss the specification of the pair. I showed you the signature and the introduction part of that specification. And I asked you to write the axioms for that pair on your own. I hope you have tried it. Some of you might have actually written the specifications and got it. It is not a very difficult specification, and if you tried, you would have got most of it at least. But anyway, let us once again look at the basic signature of this pair, and then I'll show you, I'll write the axioms for you. Once again, the pair takes two parameters, A and B. These are different sorts. They may be anything as long as these two operations are defined for both of these. That is, we have this equality defined for them, and we have this undef defined for both of these. So this is a generic specification. Anything which has these equality and undef defined could be used inside this pair, and we can make a pair out of those things. A pair, we take two arguments, first of type A, the second of type B, and we make them into a pair, join them into a pair. Then we have the methods first and second. First takes a pair and gives you the first part of the pair. Second takes a pair and gives you the second part of the pair. And this equality takes two pairs as the two arguments and gives you a Boolean result back. So let us now write down the specification for this sort. The only thing that we need to worry about is undef. So let us look at this. So here we have one constructor and the rest are inspectors. So we will just use our old style and we will use inspectors in terms of the constructor. So here we have the pair which creates a pair, and we have the first, the second, and equal. And the fourth thing that we also need to worry about is undef. But let's keep this aside and let's first write down the axioms for these three. So we say first of pair A comma B, where A is of type A and B of type B, the answer is A. Very simple, straightforward thing. Nothing very complicated about it. The second, once again, A comma B, the answer that we get is B. Therefore, in both these cases, if you go back to your old specification that we saw earlier on, the specification of quad, this is exactly the same thing. In the case of quad, we have X and Y. Here we have first and second. वहाँ पर भी दो को जोड़ के एक quad मिल रहा था, X and Y coordinates को. यहाँ पर दो elements of type A and type B, first of type A, the second of type B. इसकी type क्या है? उस केस में हमने type integer use की थी, but here we said these could be of any type. But the formulation is exactly the same. Now, the equality is going to be, once again, exactly the same thing. We wrote down the specification for equality in the case of quad. Once again, here, we are going to have the same formulation. So we say A is equal to, so pair A comma B is equal to pair C comma D when A is equal to B, equal to C, and B is equal to D. So once again, we saw there is no difference here. Very intuitive, trivial किस्म की चीज है यहाँ पर. Now, let us look at the undef. Undef क्या चीज है? We are saying that when a pair is not defined, a pair is not defined. Now the question is it not defined when both the parameters that we use to make this pair, they are not defined, or when one of them is not defined? किस तरीके से, या A डिफाइन करना जरूरी है, B जरूरी नहीं है, B डिफाइन करना जरूरी है, A जरूरी नहीं है? क्या इस तरह की कोई कंडीशन हमारे पास है? We do not have any such condition here. The only condition is that at least one of the parameters has to be defined. You cannot have both undefined in the pair. So how do we write that? It's once again a very simple formulation. We say if both the parameters that are passed, that are used to make this pair, if both of them they are undefined, then the pair is undefined. So this is what we write very simply. Note one thing here कि ये सब कुछ इस चीज पे डिपेंड करता है how do we want to specify it. जिस तरीके से मैंने पहले कहा कि अगर मैं ये कहता, अगर मैं ये चाहता कि मेरा फर्स्ट आर्गुमेंट has to be a properly defined entity. The second could be anything. It could be defined or undefined. Then I would have a different formulation. In that particular case, I would have said pair undef comma whatever x is undef. Because मेरी requirement ये है कि पहला उसमें defined होना चाहिए. लेकिन in this particular case, I did not have any such requirement. And therefore, I simply wrote कि जब दोनों ही undefined हैं, only then it is undefined, otherwise it is going to be a defined entity. So बड़ी ये simple सी formulation थी, कोई इसमें complication नहीं थी. इसी तरह की बिल्कुल इससे मिलती जुलती हम formulation देखेंगे for the second entity that we have, and that is a quad. So this quad is just like our pair, except that we have a quadruple here. So we will have 4 entities that we will group them together to make this quad. So once again, the formulation is going to be the same or very similar. Once again, the generic parameter list is going to be very, very similar. Now since we have 4 things that we need to group together, so we are saying that this specification will take 4 parameters. So these 4 parameters are going to be A, B, C, and D. in the case of pair, we just had A and B. Now we have A, B, C, and D. So basically we are saying that we can have anything here. These four could be any, as long as this equal and undef, they have been defined for them. So कोई भी चीज जिसके लिए ये दो ऑपरेशंस डिफाइंड हैं, वो आप A, B, C और D की जगह इस्तेमाल कर सकते हैं. Once again, there is nothing special about here. We have this constant undef in the quad. The rest is the same. And we have now 4 parameters. So therefore, we have 4 operations. First, second, third, and fourth. And we have this quad which takes 4 parameters. First of type A, the second one of type B, the third one of type C, the fourth one of type D, and it gives us a quad. And we have this equality operator which takes 2 quads and it gives us a Boolean result back. Now, if you look at this thing, the only difference between a quad and a pair as far as the specification is concerned is that in the case of pair we just had 2, in the case of quad we have 4. The rest is exactly the same. So for example, the first will give us the first component of the quad. The second will give us the second component of the quad, just like we had in our pair. The third and fourth, they are again very, very similar. So कोई इसमें नई चीज नहीं है. इस वजह से मैं इस पे बहुत ज़्यादा टाइम नहीं लगाऊंगा. I'll just show you the axioms for this quad on this slide very quickly without discussing it in more detail, and then we will move on with our specifications. So here is the slide and here are the axioms for this quad. The axioms, once again, we say a quad is undefined when all 4 of the arguments are undefined. So if we have at least one of them as properly defined, then we will have a defined quad. Quad A, B, C, D is equal to quad U, V, W, X is true when A is equal to U, B is equal to V, C is equal to W, and D is equal to X. The first of quad A, B, C, and D is equal to A. The second of quad A, B, C, D is equal to B. The third of quad A, B, C, D is equal to C. And the fourth of quad A, B, C, D is equal to D. So, as you saw, there was nothing special about it. अगर आपने वो पेयर की स्पेसिफिकेशन देख ली हो और कर ली हो और समझ ली हो, तो ये क्वाड की स्पेसिफिकेशन जो है ये उसमें और इसमें कोई ख़ास फ़र्क नहीं है, सिवाय इसके कि ये इसमें 4 आर्गूमेंट हैं और उसमें 2 आर्गूमेंट्स थे. Now we move on to a more interesting specification, and that is the specification of our bimap. What is a bimap? अगर आपको याद हो तो हमने देखा था रीजन, फाइल एंड डॉक्यूमेंट, तीनों केसेस में हमने देखा था कि उनका स्ट्रक्चर जो है उसमें 3 कंपोनेंट्स हैं. There were 3 components in the region, in the file, as well as in the document structure. So in the region, the first one was region ID, the second one was the region header, the third one was the link to the files that this region contained. In the case of file, we had the first file ID, the second file header, and the third pointing to the documents that this file contains. And in the case of a document, the three components were: the first as the document ID, the second one the document header, and the third one was the text or a link to the text. So these were the three components. और ये हमारे पास ये स्ट्रक्चर ये तीनों के लिए हमें चाहिए था. So this by map is going to provide us this particular structure. So what is this by map? It is basically a tuple which will take three entities and group them together, and then will provide different operations that will help us to define or to develop the specification for the filing system itself. So let us look at this slide and look at the introduction part of the by map and the signature part of the by map. So we have this specification by map which takes three arguments. The first one is the source src, and we require that we have this equality defined for the source. Note one thing here, that we are saying that source undefined is not required to be defined for the source. That means, we are not going to use undef for source. So first argument is src, which stands for source, and we need to have the equality defined for that. The second argument is, we call it target 1, and we require that the equality is defined for target 1 and undef is also defined for target 1. The third argument is target 2, with the same requirement that we have equality defined for it and undef defined for it. So the sorts that we use, as long as they fulfill these requirements, we could have anything in these three arguments. Now here we have uses something different, something new. It uses Boolean, and then we say it uses pair 1, which is a pair of source and target 1, pair 2, which is a pair of source and target 2, list 1, which is list of pair 1, list 2, which is list of pair 2, and we have an undef as a constant which is defined for by map. यहाँ पर हमने एक नई चीज देखी है. In the previous specifications, we were simply using the previously defined specifications such as Boolean. So we said, it uses Boolean. Fine. In those particular cases, we would, do something and the result could be a Boolean and so on and so forth. But here, we are saying it uses pair and list, but not in a generic term, but we are saying that it is using two instances each of these two specifications. So we have two instances of pair, and we name them as pair 1 and pair 2. So आपने जो यहाँ पर use किया है in algebraic specification, you can also name particular instances. And similarly, we have two instances of list, and we call them list 1 and list 2. साथ में हमने ये कह दिया कि जो पेयर 1 है, हमारा ये जो बाई मैप है, बाई मैप टेक्स 3 आर्गुमेंट्स: सोर्स, target 1 and target 2. So the pair 1 is, we are pairing the source and the target 1. So the first two, we are pairing them together. So it gives us a pair of these two. And pair 2 is pairing the source with the third argument, that is target 2. So हमने दूसरा पेयर बनाया source के साथ target 2. So source remains the same. Probably source is from where you reach that particular point, and source in this particular case is not going to be undefined. ये आपने अपनी आर्गुमेंट लिस्ट में देख लिया था कि सोर्स के लिए हम अनडेफ, हमें उसकी जरूरत नहीं है, और वो इसलिए नहीं है कि वी आर नॉट गोइंग टू यूज इट. इट इज गोइंग टू बी डिफाइंड. वी कैन नॉट हैव एन अनडिफाइंड थिंग देयर. So we have a pair 1 and pair 2. And then list 1 is a list of all the entities, all the sources and target ones. So when we pair them together, we make all these pairs and we get list 1. List 2 is we have the source, all the sources and all the target 2s. Those are the pairs, pair 2, and we have the list of all those. ये हमें लिस्ट किस जगह पे चाहिए? रिमेंबर कि हमने इनिशियल ओरिजिनल रिक्वायरमेंट में हमने ये कहा था कि फॉर द सिस्टम वी वुड नीड टू गेट द लिस्ट ऑफ रीजन्स. अब वो रीजन में दो चीजें थी, द रीजन आईडी एंड द रीजन हेडर. For the region, we would like to have a list of files. Once again, a pair having first the file ID and then the file header. For a file, we would want a list of documents. Once again, two things, document ID and the document header. So ये हम वहाँ पर आगे चल के इस्तेमाल करेंगे. But इस वक्त this is out of context, but I just wanted to show you, I just wanted to tell you where are we going to use this thing. So ये इसमें important चीज़ है जो हमने नहीं देखी है, और इसी तरह की चीज़ हम आगे चल के जब हम फाइलिंग सिस्टम की स्पेसिफिकेशन जब हम लिखेंगे तो उसमें भी यही मैकेनिज्म और यही टेक्निक हम यूज़ करेंगे. Let us now look at the signature part. Here we are defining if then else. So this hyphen, we have 3 hyphens in if then else. First between if and then, the second between then and else, and the third after else. So these are the 3 arguments that this takes, and it returns a bimap. So the first one is a boolean, the second one is a bimap, and the third one is a bimap, and we get a bimap back. We define the if then else for a different set of arguments, but in this particular case, the number of arguments is the same, but the type of arguments is different. In this case, the first argument is the boolean, it is a condition. The second argument is target 1, and the third argument is target 1, and we get a target 1 back. And we define if then else again, but this time the second and the third argument and the return type are target 2. So here what we have done is we have defined this if then else, and this if then else is overloaded. Since we wanted to get a bimap back in certain cases, and in some cases we wanted to get the target 1 back, in some cases we wanted to get the target 2 back, so we specified operations to get those things back depending upon that condition and depending upon the arguments. So once again, these if then else, they have been overloaded, and the distinction is made with the help of the argument list. Now let us look at the rest of the signature part. We have the equality, which takes 2 bimaps and returns a boolean back. Then we have a bimap constructor. This bimap constructor, it takes 4 arguments. So the syntax is we have this less than sign, then a hyphen, which will be the first argument, and the type of this first argument is going to be the source, comma, the second argument, which is target 1, comma, the third argument, which is of type target 2, star, hyphen, fourth argument, which is by map, and it gives us a by map back. This constructor, once again, an unusual syntax here, but there is nothing special about it. So what we do is we have a by map list. So, once again, we are not saying here that it is going to be a list or anything. It is, maybe a set or whatever. So we have a by map, and we add a new entity into this by map list. Into this collection, we add a new entity. So there are three pairs. There are three arguments that form this tuple: the source, the target 1, and target 2. So those are the three that we take as the first, second, and third arguments in this constructor, and we say put it with the by map that we already have, add it to that by map, and then give us this new modified, updated by map. So this is a constructor that we use to add new entities, new elements, new tuples into our by map. Let us look at the rest. Now we have another very interesting operation. This operation takes this by map as the first argument. Then we have this left bracket. Then the second one is the source, and the third one is the target 1, and then right bracket, and then this number 1, and it returns a by map back. Similar to this is the second operation. The only difference between these two is that we have this 1 and 2, and in the argument list, in that particular case, the third argument in the first case was target 1, and in the second case, the third argument is target 2. Otherwise, these two operations, they are the same. Then we have retrieve 1, which takes two arguments, by map and source, and it gives us the target 1 back. Retrieve 2 is similar. In that particular case, what we get back is target 2. And list 1 takes by map as an argument and returns list 1, that is list of pair ones, and list 2 takes by map and returns a list 2. तो यहाँ पर ये हमने 5-6 different operations देखे. We are going to use these operations to modify the by map and retrieve certain information from the by map and list the pairs present in the by map. The first two operations with the square brackets that we saw in this, the set of operations that we saw last, that is those 6 operations, the first 2 of those 6. Let us have a look at the signature once again. The signature is first argument, that is a by map, bracket, second argument, that is the source. Then we have the arrow, left arrow, and the third argument, that is target 1, and 1, that is by map. This is an edit operation. What it gives us is, given the by map and the source, replace the old target 1 with this new target 1 that has been supplied here. So once again, remember that we have this by map in which is a collection of these tuples which have 3 entities: the source, the target 1, and target 2. So it could be a collection of regions, collection of files, collections of documents, or anything else. मैं वो concrete example अपने context में देख रहा था, लेकिन यहाँ पर उस context का कोई जिक्र नहीं है. This is an abstract definition. So what we are doing here is, what we are saying here is that if we need to replace the target 1 of a tuple, how do we do that? This is the edit operation. And what it does is, obviously you have to tell the by map. Okay, this is the by map, and this is the source inside this by map. There is a mapping between the source and the target 1, source and target 2. So look for the source and replace the old target 1 with the new target 1 that has been supplied here. The same is the case for the second edit operator. In that particular case, it is we have number 2 with that, and now we are going to replace target 2 with this newly supplied target 2. So ये हमारे वो edit के ऑपरेशन है. Retrieve का ऑपरेशन जो है वो क्या कह रहा है? वो कह रहा है कि given the by map and the source, give me the associated target 1 back. And retrieve 1 gives me target 1, retrieve 2 gives me target 2 back. So ये हमारे ऑपरेशंस हैं, और इसमें इन्हीं ऑपरेशंस को हम यूज करते हुए आगे फाइलिंग सिस्टम के लिए स्पेसिफिकेशन लिखेंगे. बट फर्स्ट वी नीड टू राइट द स्पेसिफिकेशन फॉर द बाई मैप इटसेल्फ. So let us now do that. The first is the if then else. If true, then A else B is equal to A. If false, then A else B equal to B. If के केस में we had written 3 signatures for 3 operations. एक के केस में we had by maps, the second case we have target 1s, the third case we have target 2s. So the arguments, the पहला argument if then else का has to be a boolean. The second and third arguments, they have to have the same type. Both of these, they have to be either by maps or target 1s or target 2s. We cannot have a mixture in this particular case. ये हमारा सिग्नेचर ने ये चीज स्पेसिफाई करती थी. सिग्नेचर ने ये कह दिया था कि ये इस तरीके से इसकी फॉर्मुलेशन होनी चाहिए. And once that has been taken care of, now the rest is simple. It is the same if then else part. We are saying if the condition is true, take the first argument. If the condition is false, take the second argument. Actually, the second argument and the third argument. कि अगर case, if it is true, take the then part. If it is false, take the else part, which is the usual definition of if then else. There is nothing very special about it. But the only thing that is special, or only thing that needs to be understood, is कि then or else में जो आपके arguments हैं, उन arguments की type same होनी चाहिए जो कि हमने signature में लिख दी थी. उसके बाद ये specification जो है, ये is complete and it serves the purpose for all 3 of them. You don't have to write for by map and for your target 1 and for target 2 separately. The same will do for all of them. Then we have the equality. We say undef by map is equal to undef bimap is equal to true. So we say undef is equal to undef, and that is true. So there is nothing very special about it. Let us look at the constructor, and we write the equality in terms of the constructor. This is the same kind of formulation that we have seen in so many previous cases. The only thing is that, in this particular case, the syntax and the argument list is different, but it is essentially the same kind of formulation. So we are saying S, T1, T2 star B is equal to S prime, T1 prime, T2 prime star B prime is true when S is equal to S prime and T1 is equal to T1 prime and B is equal to B prime and T2 is equal to T2 prime. Here we have one thing important to note and remember, and that is कि हम यहाँ पर रिकर्सिवली उसके अंदर नहीं ढूंढ रहे. हमने ये नया लिस्ट ऐड की है, दिस इज नया ये ट्यूपल ऐड किया है इस बाई मैप में. So that means, what we are doing is we are maintaining an ordered list sort of thing. So ये नहीं है कि ये नया आपने ऐड किया है तो ये अगर उसके साथ मिल रहा है तो उसके अंदर कहीं पर तलाश कर लें, शायद ये ऑलरेडी कहीं पर पड़ा हो. No. Every entity has a place and that place is defined and it is ordered. अगर ordered ना होता तो फिर हमें रिकर्सिवली इसके अंदर ढूंढना पड़ता और फिर हम उसकी इक्वेलिटी हम उस तरीके से लिखते. बट यहाँ पर हम इसको ऑर्डर्ड लिस्ट के तौर पे इसको ले रहे हैं. देन वी राइट S, T1, T2 star B equal undefined is false. Then we say undef S left arrow T1 is undef. So the bimap we are supplying here is undefined, hence what we get back is undefined. So we cannot modify anything because the bimap itself is not defined. The same is the case for the second editor function. Now we write the editor in terms of the constructor. So the first argument is a bimap, and that bimap we get after applying the constructor. We say this constructor S, T1, T2 star B. This is the first argument to this editor. S prime, that is our sum source, and we say T, and then this is 1. So what we are saying is that in this new bimap that we have got after applying this constructor, look for S prime and change the target target 1 associated with S prime and replace it with T. So this formulation is very similar to the formulation that we had, that we have seen a lot of times, and this is the recursive formulation. And we say if S is equal to S prime, then we are simply replacing this T1 with T. So we say then S, T, T2 star B. So T1 would be replaced with T. Else we add this S, T1, T2 after replacing T where we have the source S prime in B, and then applying this operation onto that. Similarly, we write the specification for the second editor function. It is exactly the same formulation. So यहाँ पर हमने कहा ये जिस तरीके से हम पहले लिस्ट वगैरह के केस में हम देख चुके हैं, बिल्कुल एग्जैक्टली ये वही फॉर्मूलेशन है, कोई इसमें कोई खास चेंज नहीं है. उसी तरीके से रिकर्सिव फॉर्मूलेशन हमने की है. So we have now retrieve 1 for undef. Obviously it is undef. Retrieve 2 is the same. And then retrieve 1 for this constructor S, T1, T2 star B, X. So once again, the same kind of recursive formulation. If S is equal to X, then we return T1, else we are going to retrieve the first argument from the old bimap given X as the source. Retrieve to is exactly the same formulation, except that in this particular case, now we are trying to get the second target 2. Now let us come to list 1 and list 2. List 1 for undef. And now we are saying that, what we get back is not undef, rather what we get is an empty list. So list 1 undef is an empty list. List 2 undef is 0, which means an empty list. And now we write, use the constructor. So list 1 S, T1, T2 star B is equal to pair S, T1 dot list 1 B. Similarly, list 2 S, T1, T2 star B is equal to pair S, T2, that is the newly added tuple. So this pair has been taken from that, dot list 2 B. So ये जो हमने जो आखिरी जो स्पेसिफिकेशंस देखी है, आखिरी जो एक्सियम्स देखे थे, इन एक्सियम्स में लिस्ट 1 और लिस्ट 2 के अलावा बाकी चीजें बड़ी वो सिंपल सी हैं. रिट्रीव के फंक्शंस देखे, लाइक आई सेड, उसी तरीके से पुरानी ओल्ड स्टाइल फॉर्मूलेशन थी. और यहां पर भी लिस्ट के केस में भी वही ओल्ड स्टाइल फॉर्मूलेशन थी. सो व्हाट वी आर सेइंग इज कि हमने ये ट्यूपल लिया जिसमें ये तीन चीजें हैं, एस, T1 एंड T2, सोर्स, टारगेट 1, टारगेट 2, और हमने लिस्ट ऑफ पेयर्स 1 बनाना है, लिस्ट 1 बनानी है, विच इज ऑफ लिस्ट ऑफ पेयर 1. पेयर 1 क्या चीज है? सोर्स एंड टारगेट 1 को हम पकड़ना है. तो इस ट्यूपल में से सोर्स एंड टारगेट 1 को पकड़ लिया, so that will be one node, one element in that list. और बाकी जो आपकी प्रीवियस जो आपका बाई मैप बी पड़ा था उसमें सारे आपने पेयर्स उठा लिए और इसको कॉन्केटिनेट कर दिया, ये वाला पेयर उसमें ऐड कर दिया. सो यू हैव ऑल द पेयर्स दैट यू वुड हैव इन द न्यू लिस्ट. द सेम इज द केस फॉर लिस्ट 2. सो द बाई मैप की स्पेसिफिकेशन आपने देखी, हमने ये कंप्लीट स्पेसिफिकेशन दी. इसमें एडिटर फंक्शन भी हमने देखा, इसमें हमने लिस्ट के फंक्शन भी देखे, और इसमें हमने कंस्ट्रक्टर का फंक्शन भी देखा. देयर इज नथिंग वेरी डिफिकल्ट अबाउट इट वंस यू अंडरस्टैंड इट, वंस यू अप्लाई द लॉजिक प्रॉपरली. इट इज एग्जैक्टली द सेम थिंग और ऑलमोस्ट द सेम काइंड ऑफ फॉर्मुलेशन जो हम इससे पहले बार बार देख चुके हैं. तो जो चीज सबसे ज्यादा आपको इंपॉर्टेंट यहां पर सोचने की और देखने की है, वो ये है कि इस तरह की फॉर्मुलेशंस में रिकर्जन किस तरह इस्तेमाल हो रही है. तो रिकर्जन इज अ वेरी इंपॉर्टेंट एंड पावरफुल टूल दैट यू वुड नीड टू राइट योर स्पेसिफिकेशंस, डायरेक्ट एंड इनडायरेक्ट रिकर्जन. और ये हम बहुत बार इस चीज को हम देख चुके हैं. तो ये बाई मैप की स्पेसिफिकेशन कंप्लीट हो गई. इन द नेक्स्ट लेक्चर वी विल यूज ऑल दी स्पेसिफिकेशंस दैट वी हैव डेवलप्ड टू कंप्लीट द स्पेसिफिकेशन ऑफ द फाइलिंग सिस्टम इटसेल्फ. उस वक्त तक के लिए आप मुझे इजाजत दीजिए. खुदा हाफिज और अस्सलाम वालेकुम.